Hey guys, today we're going to be talking about recursion. Recursion is a programming technique where a function calls itself in order to solve a problem by breaking it down into smaller, more manageable subproblems. You can think about recursion as a set of nested dolls. Each time you open a doll or make a recursive call, you can find a slightly smaller doll inside until you get to the smallest doll, which is the base case, and then you return all the way up to the very first recursive call, in which case the problem would be solved. So I'll be showing some code examples. I'm going to start off by showing a factorial not using recursion. Alright, so this is just a normal function using a while loop, no recursion involved. And you see when we call it, it returns 24. And all this is doing is making a new total by multiplying itself by num and then subtracting num. And once num is less than 0, we return the total. So how we would do this in a recursive way is like this. So you see, we call it, returns 24, and the different parts of this function are the base case right here, which we need or else the function would run on forever and produce a Stack Overflow error. And here is the recursive call. So we call factorial of 4. We go through, num is not equal to or less than 1. So then we return num times factorial num minus 1, so 3. And then we go through again, check if num is less than or equal to 1. It's not, return factorial num minus 1, which is 2. Go through again, factorial is now 1, so then the base case is returned. And once the base case is returned, then it gets multiplied by num from the previous local variables. So it breaks out of this function because it returns. So then it's in factorial 2, which is num, so 2 times 1, it's now 2. And then it breaks out of this because of the return. So now it's 2 times 3, which is 6. Breaks out 6 times 4, which is 24. Makes it through the whole thing and console logs factorial 4. So you probably wouldn't use a recursive function to just produce a factorial like we're doing right here, but you would use it when you're trying to find the nth number of the Fibonacci sequence, as we're doing right here. So this one is more complex because it has 2 recursive calls instead of just 1. And as you know, the Fibonacci sequence is just adding the previous 2 numbers in the sequence to make the current number. So we have n minus 1 plus n minus 2, and once these go all the way down to 1, then it's returned, and like in the previous one, it pops out and adds up, pops out, adds up, pops out, adds up, until it reaches the Fibonacci sequence of 10. So I'm going to save this, and it should return 55, as you can see right there. And this last problem, I think, demonstrates even better what I'm talking about. So I have different console logs here that show the depth of it and shows how it's entering and leaving the different recursive functions. So this is just a copy of this function right here, but all that it's doing is console logging on what step of the recursive function it's on. So I'll run this function and then I'll explain what it's doing. So we call factorial 4, go through this console logs, so it's entering factorial of num, which is 4, and then we go through, we call factorial recursively again, and we pass in this depth property, and all the depth property is doing is just giving this indentation. So when we call factorial again, entering factorial 3, go through again, call it, entering factorial 2, call it again, entering factorial 1, and as you can see, it hits the base case, so it returns 1. And then all of these, after they've been called, they go to the next line right here and console logs all of these. So it's returning 1 from factorial 1, which is right there, returns 2, because that's the result currently, from factorial 2, returns 6 from factorial 3, and returns 24 from factorial 4, because it's taking the product of factorial, whatever it's on, factorial n, and multiplying it by num. And finally, once it makes it through all of these, it returns the final result and breaks out and then console logs factorial 4, which is right there, 24. So that's a quick explanation of recursion, and as you can see, these console logs kind of show the local plane or the snapshot as I talked about in the last video. So I hope that makes a little bit more sense. Thanks for watching, and be sure to like and subscribe.